Awesome. Okay. Thanks everyone for joining. This talk is about dealing with unprecedented scale during COVID-19. So largely talk about what happened last year, because we're a little bit kind of out of the weeds there, touch wood. But still an interesting case study nonetheless, and scaling and how the web deals with this typically. So just really quick introduction about myself. I'm Sean Hamlin, a technical account manager with Amazee.io, and I work with some of our largest customers in region in Asia Pacific, and generally look to solve complex problems and help make sure that what we're doing today is going to enable success in the future. So you can find me on email, Twitter, and LinkedIn there. And first up, just a big thanks to everyone that's shown up and taking time out of your busy day. I really appreciate the investment you've made. So yeah, if you do want to ask any questions, just feel free to interrupt. I don't mind. You can unmute yourself. This isn't a traditional webinar; it's more of a traditional Zoom. So yeah, feel free to jump in. But as I said, you can leave it to the end as well if you're more comfortable off recording. Quick recap of the agenda. So we're going to go through some short fire overviews in 1 minute. We go through COVID-19 and what this meant. Show off some of the numbers that we ended up dealing with. I'm going to talk about horizontal scaling and what this means for applications. About database sizing, scaling, and tuning, caching in RAM, helping to minimize your origin hits, and CDN tuning. So kind of like a combination of different technologies here. And lastly, kind of a footnote on why you should care about any of this. So some of the overviews is Amazee.io in 1 minute. We're a global managed service provider, and we have a web ops solution called Lagoon, which is open source, and it's built to basically translate your Git repository into stuff that runs inside Kubernetes. So it helps to kind of abstract all that kind of hard stuff away. And if you want to know more about Lagoon, there is actually a talk tomorrow by Toby, called Deploying Web Applications on Kubernetes Without the Pain. So if you want to know more about how we do this translation layer from a Git repository to Kubernetes, I'd recommend you jump into that. And a bit more about Amazee.io. So our tagline really is host anything, anywhere in the world. So we can host your application on any cluster that supports like a managed Kubernetes offering with a managed database offering. So it's pretty low barrier of entry. So that means in practice, AWS, Google Cloud, Azure, Catalyst Cloud, and even some of the other ones like Alibaba and stuff like that. And we have chat-based support and also ticket-based. And I guess the main theme there is we're heavily into open source, and we kind of keep that ethos in our team. We're incredibly transparent, and the work we do on Lagoon, for instance, happens in the clear in GitHub issues. And yeah, we've got a bunch of local partners in region, so we work with a lot of people you probably already know. And one of those people is GovCMS, which is, for those who don't know, it's a program run out of Australia by the Department of Finance. And they provide the 3 tiers of government in Australia, so the federal, state, and local level. And we're one of their technology partners, along with Salsa Digital. And it's been operating for a few years now, since January 2015. And there's roughly 340 odd, give or take, a few sites live as of today. and they're all shapes and sizes. Some of them are tiny, get like 1,000 page views a month, and some of them are the opposite. So the sites I'll be talking about today are the bigger ones. And yeah, it comes in two flavors, like a SaaS or software as a service, which is more locked down. You can bring your own theme, but not so much any modules or custom code, or a platform as a service offering, which is, bring whatever and, it'll better be hosted there. And Department of Finance take care of a lot of the tricky things around accreditation. That's quite a ordeal that needs to be done every so often. A little quick disclaimer. So the stuff I'll be talking through in this presentation will mention some topics like Amazon Web Services or AWS, and also Kubernetes and containers. And no pre-existing knowledge is required. So I'll make all the explanations using really weird metaphors. So if it doesn't make sense, just let me know. So a little bit about COVID-19 and what this actually meant for a customer like GovCMS. They actually have several sites that were directly impacted by COVID-19. The biggest of such is health.gov.au, which is kind of equivalent to New Zealand's health.gov.nz. And it's the authoritative source of information for all COVID-19 information in Australia. And there's obviously state-based health sites as well, but they all kind of roll up to the federal-based ones. There were several travel-related sites, like Smart Traveller is a site that tells people in Australia whether they should fly to a country, whether they should be flying home, what the risk levels are and stuff like that. That was actually quite key during the initial stages of the pandemic. And the services that kind of wrap once the government kind of gets their head around it is like they had this payment called the job seeker payment in Australia, which not too dissimilar from what New Zealand had around the 80% wage thing. This generated a lot of traffic to sites like Services Australia, which help administer the job seeker payment. And when we look at, this is probably late March 2020. What actually happened was there's a COVID-19 app in Australia, and it has the ability to send out a push notification. So what actually happened was they sent out a push notification to Australia, as far as I could tell, at the same time without staggering. And that generated a bit of traffic on the sites. And this was seen in Google Analytics in the real-time display. And if you've ever seen GA with numbers that go this big, it's very scary. It was certainly a sight to behold. And what that ended up generating was, in the peak minute, I think it's just shy of 100,000 page views in that peak minute. And that was just on the health.gov.au site. On that day, they smashed out 8.4 terabytes of bandwidth, which is a scary number. And I'll show you a graph shortly, but the health site itself went through an 80 times traffic increase from the month of March compared to the previous calendar month of February. And I can't show you the numbers on the y-axis, but you can get a sense for the scale of the response. So each color represents a site here, and this goes all the way back to the inception of GovCMS back in 2015 here. And I still remember when GovCMS had 1 million page views a month, and that was back here, let's just say. And this is February here. You can see February had an increase over January, and it had an increase over December. But the real increase came in March, and this color, this kind of funny green color, is actually the health site. So you can see here's where they really stepped up their traffic. and you can see primarily the traffic's made up of just a couple of the larger sites with, some bits on top. Yeah, and subsequent, it actually has kind of fallen off, and I haven't updated the chart since then, but it hasn't got anywhere near back up to the same traffic levels anymore. So some of the tools that we had in the toolbelt to deal with this type of traffic, horizontal scaling is probably the first one I'll talk about. And when I say horizontal scaling, I mean basically this, like being able to increase the resources available to your application in response to traffic. And ideally, this should happen in an automated fashion, because sometimes, especially during COVID, we actually had no idea there's going to be a traffic spike because we weren't privy to, what was actually happening in the health department at any particular hour of the day. We just had to be prepared that something was probably going to happen, and we should plan for that eventuality. So in Kubernetes, this is done with a couple of technologies. One is called a horizontal pod autoscaler, and the other one is called a cluster autoscaler. And here's a weird metaphor number one. We're going to talk about horizontal pod autoscaling using a supermarket. This is the easiest kind of way I could think about it, explaining it. So at a supermarket, you have a checkout supervisor, which is overseeing what checkouts are open, which ones are closed, and generally keeping an eye on the customers that are waiting. We've got some minimum number of checkouts that are open at any one time. So the supermarket can never have no checkouts open. That would make any sense. So there has to be some. And there's people buying stuff in a queue. And when the queue gets past a certain amount and people are waiting for too long, the checkout supervisor might decide to scale up the checkouts so that the people can be distributed amongst the checkouts more efficiently and get their groceries purchased quicker. So if we take this back to Kubernetes concepts, what this means is the checkout supervisor is actually the horizontal pod autoscaler. It's in control of making sure there's enough pods to service the incoming HTTP requests. So like in essence, it's adding and removing resources in response to traffic. And the metaphor breaks down a little bit here, but if you were to say run out of checkouts, like physically run out of checkouts in your supermarket, then if it was Kubernetes, you'd buy another supermarket right next to your previous one, and you'd open up more checkouts there. So the metaphor kind of breaks down a little bit there, but that's the cluster autoscaler in action. So the cluster autoscaler is about adding additional physical resources into the pool so that there is space available for more pods. So with GovCMS during the pandemic, we actually came up with standard configuration for any site that was impacted by COVID, and we called it the COVID HPA, which would start at 4 application pods as a minimum, would scale to a maximum of 12, and would scale very quickly. So it wouldn't really muck around, it would get straight into it as fast as possible. And then for any of the more impacted sites like Health and Services Australia, we would do daily reviews of their HPAs just to make sure that we had them as optimal as possible, because every day things were changing and we had to just make sure that we were staying on top of it. Yeah, and I'm primarily looking to avoid, I just coined this term, but pod flapping. So if we take this back to the supermarket, you don't want to open a checkout, serve one person, and then close the checkout, and then wait 5 minutes, open the checkout, serve one person, and close the checkout. Like it gets incredibly taxing on the people doing that. And the same thing goes with Kubernetes. You don't want to be adding a pod in for a couple of minutes and then taking it away only to add it back again. And so you want to think about setting the minimums appropriately. So this graph here is for one site. and the y-axis is requests per minute, and the colors indicate the pod that served the request. So you can see at the left-hand side here, we've got 1, 2, 3, 4 pods. That's the minimum currently for the site. And you can see as the kind of day progresses, a 5th pod comes in here, then goes away. 5th pod comes in, goes away. And then like we start to see the 5th pods become permanent about this time, and then a 6th pod become permanent about this time with additionals on top. And you can see some pretty gnarly traffic spikes, 3,200 requests per minute at this point here. So based on looking at these numbers, I would probably recommend the minimum be changed to 6 pods, because we were seeing a bit of pod flapping here, and we still needed 6 pods for the majority of the day. So anyway, that's the type of stuff we were doing on a day-to-day basis, is just sort of reviewing these metrics and then setting new baselines for the application. And GovCMS runs Drupal, and for those who know a little bit about Drupal, is that it's incredibly hungry in the database. A given page load is maybe 200 SQL queries, and I wish I was joking, but I'm not. So just adding application pods to the cluster isn't necessarily going to solve all your problems, because your bottleneck may eventually become the database. And you can run a database in the pod. It's just a poor life choice, so we don't do it. Just mainly because it's a single point of failure and it's super hard to scale it. So instead, what we end up doing is using a service from Amazon called Relational Database Service, or RDS, and specifically the Aurora variant. And it's got a few features over vanilla MySQL. The main one that we like is faster failovers with no data loss, which is incredibly important for what I'm about to go through. So this actually happened for Services Australia. We needed to make their database larger, and yeah, this is just going through that kind of as slow as possible. So in an RDS, you have what's called a cluster writer endpoint, which points at the current writer instance. And a cluster is typically 2 instances, a writer and a reader. And there's replication running from the writer to the readers. If we wanted to make both of these larger, these instances, say at the moment they're large, we want to make them X large, which is just a t-shirt size. But say we want to double their size. Then what you end up doing is you upsize the reader first. It's now twice as large. That can be done at any time. And then you fail over the cluster. So the reader becomes the writer, and the old writer becomes the new reader. And this is all done through RDS. So your application is entirely, it doesn't even know this is happening, to be honest. It just keeps going with the flow. And then after that's taken effect, you can then upsize a new reader. So that's a rather complex process, but it's made a lot easier by Amazon. And yeah, this is just kind of sums it up quite nicely. No one ever upsizes their database unless it's getting absolutely crushed. So like when you do the upsize, you need to be confident it's going to work at, under extreme load. So we're able to get this down to around about 15 minutes end to end for the upsize. And during that time, the actual application is running and still serving pages to end users. And we managed to count, there's like a 30-second period in which 50 SQL queries ended up like not completing successfully, which is, it's not perfect, but it's not far off when you're getting, as many pages per second as these sites are. And we ended up upsizing Service Australia twice in 2 days. So they actually went to 4 times as large as what they originally started. And in Amazon, there's a service called Performance Insights, which you can see into the actual load of your RDS clusters. And this is an example of what I call a SAD performance insight. So it's not very happy because the load, or the bars you see here, is actually exceeding the dotted line, which is the number of virtual CPU cores. So in general, you want to have the load under that, because then the queries execute as fast as possible and the database has got a bit of headroom to absorb some spikes. So this I would not be too happy with seeing. Whereas this database cluster, for instance, has got a much higher virtual CPU count, and the queries are staying much lower. So we're looking at a spike of maybe 8 out of the 16. So that's it's got a lot of headroom, and I'd be much happier seeing that. My other pro tip would be in Performance Insights, for those that have seen it, is it starts at a 1 hour resolution for those graphs. Just change it to 5 minutes, because you end up seeing a lot more detail. This is at 1 hour and everything looks pretty rosy. You know, you can see all these kind of bumps have all been smoothed over. But if you go to 5 minute granularity, you can actually see that there's actually some pretty significant spikes that are happening in here. And yeah, anyway, it's just a nice little way to get a bit more accurate information out of it. In-memory caching. So Drupal loves to cache things, and the database is definitely not the fastest place to store this cache, and especially using systems that are getting a lot of load. So we use a technology called Redis, and Redis is essentially a key value store stored in RAM. So it's extremely fast, extremely simple, and works quite well with a lot of applications like Drupal and Silverstripe, etc. We've got 2 options for Redis. We've got either a pod, which is just a single instance of a pod running in the cluster. It's not highly available. It is a single point of failure. It's probably more suitable for smaller sites that don't have a lot of traffic. And there's another option, which is highly available. It's replicated across availability zones, etc. In Amazon, this is called Elasticache. And Elasticache is, yeah, Redis as a service, effectively. Yeah, and we had to do a few migrations from pods to Elasticache during COVID for a few key sites. It's some of the hallmarks become apparent, but it's not time to use a pod when you require high availability. So if you were to lose your cache at any point, would the application survive the resulting stampede that would come next? If the answer is yes, then you probably don't need high availability. But if the answer is actually no, the site will get crushed, then you need to look at using Elasticache. We started to see problems with the pod receiving 60 megabytes per second of traffic in and out. That seems to be some sort of inherent bottleneck. So if you're getting a lot of numbers there, then you probably want to look at Elasticache. And the other pro tip is make sure you do configure the application to use a Redis timeout. So rather than waiting indefinitely, if it can't connect to the Redis cluster, give it a timeout of a second, and that way it'll give it a go. If it can't reach it, it's got a sensible fallback, and it's not going to spend all its time just spinning wheels. Minimizing origin hits. So the best place to generate a page view is not on your hardware, like at all. So yeah, the best place to get those pages out to is the CDN. So in order to help minimize the traffic getting through them, we've got a couple of tools at our disposal. Elasticsearch and Kibana is the tools of choice. And we've got a site health dashboard, which we can create for any GovCMS site. And I'll go through what one of those are. But yeah, an incredibly powerful graph that we've got is bound to sum origin responses by their actual aggregate time descending. So rather than just having the most popular pages to origin, is actually the most impactful, which is a slightly different way of looking at it. So this is an actual site and an actual dashboard. At the top, we've got status codes, so like HTTP responses. So green in this case is HTTP 200 and is good. So you want to see a lot of green. You don't want to see a lot of 500s, a lot of 404s, you know, just a lot of stuff that's, you know, the application not going so well. We have top 404s by path. So here you can see, well, the text is probably quite small, but there's a bunch of Apple Touch icons missing. So if they were to fix up something on their site that was super easy, yet going to provide some meaningful impact, would be, can you just add the Apple Touch icons and like fix up all these 404s? We've got the pod scaling. This is the same graph I showed you earlier with the requests broken down by pod. So you can see at a glance how the pods are coming in and coming out, and generally what kind of scale is the site getting. We've got top requests by path and method. So this is just, yeah, you can see favicon to ICO as the top requested path and origin, probably because it's a 404. But if we actually break it down by path method, but sort by the aggregate time spent at origin descending, you see different pages here. So their coronavirus page occupies 10.6% of all requests to origin, of all time spent on origin, sorry. So if they were to optimize any one particular page, it's probably that page. Can they cache that page for longer? You know, questions like that. And down the bottom is top user agents. So which can come in handy if you're seeing particularly unusual traffic, like is someone trying to do a crawl or a scrape or something like that over the site, and you need to tighten up your WAF. And yeah, talk a little bit about CDNs, but in general, they're crucial to the success of the program. And my only advice there is make sure you pick a major player. Ensure that they have key features like just distributed denial of service protection or DDoS protection. WAF and bot management. And by bot management, I mean being able to respond to people executing like crawls and scrapes and stuff like that across your site. Serve while stale is incredibly important. Like say the origin did have an issue, or say you're doing a deployment, or say you need to take the site offline for whatever reason. You want the CDN to keep serving the last known good response, because that's likely better than an error page. So serve while stale should hopefully be, you know, one of the top requirements that you have in your list. Negative caching, if you do get a 404 for like favicon to ICO, it's probably going to be a 404 the next time you request it. So most CDNs will have the ability to cache these error responses, these 404s, for some amount of time. That's called negative caching. So you might say 10 minutes this 404 is valid for. So that means after 10 minutes, the next request would go back to origin and check, is it still a 404? And if it is, 10 more minutes. That's just helping to reduce the traffic to origin. Background refresh. So you should ideally never have the customer wait for a response from origin. So if the home page was, say, just marked as invalid just outside of its range, then the end user should get the last known cache copy, send it back immediately, and the CDN can do a background refresh of that page. So that way the background refresh is slightly slower, but it's okay because it's just the CDN doing it. And end users get the same snappy pages every single time. Drupal has something called cache tags. So rather than purging by URL, which can be cumbersome and tricky if your site is complicated, cache tags is an effective way to snipe your CDN cache based on the contents of the page. So yeah, if you do, like, say, edit like a piece of content, you're not invalidating the URL that's on, but the fact you're just invalidating that one tag, which could be on many pages, but you don't actually need to know that. And the last thing there is like what is the next best alternative? Like, and by that I mean, like, it's all too often you see a site that gets crushed by traffic and say all the scaling in the world couldn't help it. Like, what's the next best thing you could do to help make the end user's experience not terrible? So, obviously server style is a great example there, but another option that some sites do is they render the site static and stick it on S3 or something like that. So as an absolute worst case scenario, they can flip the switch and serve out of the S3 bucket. It's just like this, just coming up with those scenarios on what you could do is the next best thing. Like, ideally, what could you never want to serve an error page to your end users. So how can you think about ways and means to do that better? And like, how do you get there? I like to use this a lot in my day-to-day, but this culture of continuous improvement, and it's been coined by a Japanese term called Kaizen. So Kaizen is all about build, measure, learn. So doing iterative development and making things better, even a little bit at a time. So like, things you could look at doing to help on actual websites today is like, how high can you get the cache hit rate? Like, how high is high enough? I've seen a cache hit rate of 99.975. Like, that is incredibly high. And that means that 25 requests out of 100,000 will make it back to your origin. So like, that is something I think everyone should aim for. And like, if you're on, say, 90 or 93 or even lower, what's the next most popular page or the most impactful page making it through the CDN, and how can you avoid doing that? If you are using like MySQL or something, you can turn on the slow query log and find out what queries are taking longer than, say, 2 seconds to execute. The top 404s I've already mentioned, but these are simple cleanups. Normally, they could be chucked into the next sprint as a very tiny ticket. And if it's just adding some Apple Touch icons to the doc root of the site, then that's like maybe a 10-minute job. Can you upgrade your version of PHP? Because newer versions of PHP are faster on top of the security benefits. Like, can you be on 7.4 or even 8.0? If you're not using cache tag purging, what's stopping that? It's really key to the first point. And Drupal specifically, you can stop certain cache tags from being purged. So if you, for instance, want to edit your footer menu, the one thing you don't want to do on a Drupal site is edit the footer menu without configuring your block list, because otherwise you will effectively obliterate the cache for the entire site. And that sounds like a fun thing to do until it's peak COVID times. And in general, just look to your team and see what they can do to actually come up with these small iterative improvements. And get them into the habit of never being done. It's just something that you do, and you're always on the journey. And this is kind of shared around LinkedIn a few times, but the principle is what I like the most, which is if you do a 1% change for the better, and you do that enough, then you actually end up with a huge improvement over time. So even if you think, what's a few Apple icons going to actually do to the site? Like, actually, if you do a few changes like that over time, eventually they'll compound, and eventually your cache hit rate will be, 99 point something. And why should you care? So this whole presentation was hopefully aimed at this one kind of point at the end, but I really enjoyed this quote. So this came out of Services Australia after things had settled down. The dust had settled and everyone had a chance to recollect on what actually happened. And this is from Susie Smith, GM of Comms. So yeah, it meant that we were able to supply information to the public during a pandemic with no outages. This supported real people and the ability to care for themselves and their families. Because Services Australia were on the hook for the job seeker payment, they were kind of on the front lines on getting money out to people that had lost their jobs. So this was huge, and this was a really great quote from Susie. Really enjoyed that. And that is my presentation.